Greetings, my name is Elwin Wei Jie and my metric number is 221061394. Today, I'm going to walk you through the motion control template for single axis conveyor that I have developed using Siemens Porter B16. So, the system actually uses a modular function block called FB positioning axis, as you can see here, FB100, that handles all key tasks such as reset, homing, jogging, and movement, while also monitoring the status and errors for the single axis conveyor system. So right now, I'm going to show you the instance data block. So you can see there are inputs like execute motion control reset, execute motion control power, so on and so forth. And all these commands are passed from a structured data block, and outputs such as motion status, speed, and error states are returned. This modular setup also allows the reuse for additional axes by simply creating new instances. So actually, you can just create new instances in here in this menu. So next one, I'm going to show you the FB positioning axis, the network for this template. So network one actually represents the reset. This is used to clear the errors before the motion begins. And network two is used to check the readiness of the axis. And then network three powers, which actually power ups the axis using the MC power. And network four performs homing. Network five to network six to control movement drop and velocity. And network seven and network eight execute relative and absolute positioning. And network 9 and network 10 handle halting and stopping. Network 11 collects live axis data such as speed, as you can see here. It collects data such as actual speed, velocity, and positions. And then network 12 added a standstill detection by checking if the speed and velocity falls within a small threshold. If yes, the output standstill is set. Okay. This ensures the axis is idle before other motions. Next, for the network 13, it handles the global error detections. So it checks the axis error and the error outputs from all the motion blocks. If any of these reports an error, output MC error is raised. So this is used for diagnostics and safety purpose. So right now I'm going to run the simulations. So right now I've opened the configuration menu for this template. So as you can see, I set it, you can choose either linear or rotary motions for the motor. And then you can also change the unit of measure for position, velocity, and the unit for torque. So right now, returning to the commissioning menu. So if I press activate for the axis control panel and I press enable. So that's, you can see there's a set home position, homing, drop, speed, set points, absolute relative and absolute positioning. So we'll start with homing. So as you can see, the initial position is 0. So let's say we set it to 10.0. All right, then we press start the simulation. So press forward. And then this is the speed set point. So if we press forward, as you can see, the values of position is rising, means that it's moving. Then we press stop. And then we set to the home positions. So previously we set the home position to 10. So right now, if I press start, so the current position will be back to the 10 degree. So let's say the positioning. So let's say I set the distance of the relative positioning to 360. Sorry. All right, so for the relative positioning, I've set the distance to 360 and the velocity is 90 degree per seconds. So I press forward. So as you can see, the latest position will be 370 because 360, the position that I set, and then plus the home position, which is initial is 10. So moving on to the wash table for this template. So first of all, as you can see, there are all the functions are included here. Start with reset. So I will turn on the MC power, which will turn on the module. So just modify it to 1. So this one will turn on the whole module. And then I will start with the jog forward. So when I switch to 1, so as you can see the value here, it's switching. It's increasing. Then I need to stop it. And then as you can see, the value is 1430. Okay. And then I'll start with the jog backward. So as you can see, the value are decreasing right now. Okay, that's for the jog backward. So modify to 0. So right now, the value stops at 622.4. So right now, I'll test the move relative. For the move relative, let's say I input the distance for the move relative is 160. So I'll set the value here, 160. So which means when I start the MC move relative, the value will be 622.4 plus 160. So I start right now. Some problem is rerunning. Okay. So as you can see, just now is 622.4. Right now it's increasing to 782.4, which means it's increased by 160. So as for the move absolute, let's say I input the value of 700. So when I start it, the value will change from 782.4 to exactly 700.0. So just modify 0, and then for some reason this function is not running in teleporter. So that's one of the problems right now. Yeah, it's not working. So now as for the MC halt and MC stop, what's the difference is halt will stops the system gradually, but the MC stop will stop the system immediately.